And this week's topic is Hydronic System Solution Software, or HSS software. Most of the webinars that we do, and hopefully you guys all know that every single Monday we do a different webinar at noon throughout the entire year. We record the vast majority of those. Usually it's on some kind of product or application type thing. Although in this case, we're actually going to do it on a software package. It's not a software package that we sell or represent or anything like that. It's just one that I've used several times over the past 5-6 years, and I like it a lot. And it's free, and free is usually the price point that I get excited about. So with that, I'm going to show you the software tool. I got 4 or 5 slides I'm going to show you at the beginning just to kind of explain what this is. And the rest of what we're going to do is we're just going to draw stuff up on the tool. And what I'll do is I'll just draw as we go. And if you have questions about can it do this or can it do that, I'll do my best to bring up that on the screen at the time. So it's kind of like a software demo type thing. All right, so like I said, the software is HSS software. If you want to get a free copy of it, you can get it from the Multi-Aqua website, and I will show you that shortly where you can download it from. They are one of many sponsors of the software. Taco Pumps is the primary software sponsor. It's kind of their software package, if you will. But they've worked with numerous other manufacturers. In our case, Multi-Aqua offers it free to us through the chiller line that we handle for them. But there are, I think it's 37 different manufacturers that are involved in sponsoring this software at this point. Many of them are products that we handle here at TEC and Excelsior, such as Multi-Aqua, Meztec, Utica, ClientMaster, SlantFin, ECR, Elite Software. So there's lots of different partners involved, 37 of them in total, plus there's, I think, 22 universities that are involved with partnering on this software. So lots of groups are involved in lending their expertise and their cash in some cases to make this software happen. But Taco is the primary sponsor. And this software will allow you to draw professional-looking drawings. It'll size piping for you. It'll size pumps for you, expansion tanks, things like that. Many of the selections will default to Taco. You don't have to use Taco products, obviously, but the pump selections and expansion tanks will be Taco by default. And you can also do the same thing with some of the boilers and chillers. You can have them default to a specific manufacturer if you wish. I won't spend a lot of time showing you examples on the screen here because we're actually going to draw stuff up on the fly. But this software is not just for hot water systems. We can do hot water, we can do chilled water, we can do industrial piping, we can do swimming pool piping, we can do geo, we can do radiant floors. Although I will tell you with geo systems, you're going to be doing, it's going to help you draw the indoor portion of that system, and the geo loop field you'll be doing with a different software package, but you would be connecting these systems together, obviously. Same thing with for radiant. As you can see, even on this drawing up in the right corner, there's a little radiant example. But it's not going to draw out the radiant tubing layout for you. It's going to help you draw all your piping systems to the radiant floor. So we can mix and match hot water systems, hot water, chill water, condenser water systems, swimming pools, process, anything like that. I'll try to show you as many examples as we go through the software, things that we can feed into it. So these are just different examples on here. And these can be fairly simple drawings like the ones we have up here with 3 fan coils and 1 chiller on this particular case with a pump and expansion tank and an air separator. Or they can be more complex systems. We can do an entire high-rise with these things. We can do, in this case here, a geothermal chiller we piped up using this software. So you can see on the bottom right-hand corner it's showing you a geo field. Now this software, like I said, doesn't do the geo field, but it helps me do the design for everything inside the building. So coming out of my geofield, I just specify the temperature ranges that I have, and in this case you can see I have both summer and winter temperature ranges, and they're providing to the condenser side of my chiller, and then the chill water side of my chiller is going to all my fan coils and so forth. So we'll try to draw some of these up today. Real quick, I'll show you on the websites. I'll drag these over here so you can see where you can get some of these things. So the software itself, if you want to download it for free, you go to www.multiaqua.com, M-U-L-T-I-A-Q-U-A, and you scroll down on the left-hand side here, and you'll see where it says HSS Hydronic System Design Software. If you click on that, either on the picture or on the link, it'll take you to the registration site, where you basically fill in your general info, and then it'll allow you to download the software for free. So that's how you get to the software. The software that you'll be downloading for free, either from Taco or Multi-Aqua or from one of the other partners, is the Hydronic portion of the software. The software also does airside and duct design. That's for the pro version, if you will. And If you're looking for the Pro version, that you can get from the software company's website, which is hvacsolution.com. So www.hvacsolution.com. You can look at what's involved in the full professional version if you want that software. The other nice thing about this site is if you go to the tutorial tab, you can watch a bunch of short videos on how to do different things. So there's all kinds of different categories of topics on stuff you can do, and watch little videos and then go ahead and actually do it on your screen. So if I clicked on the Hydronic portion, you can see all the videos that are on here you can watch. So that's a pretty useful tool. So Multi-Aqua to download the software for free, HVAC Solution to watch the videos or to buy the full version. Now when I say the full version, that doesn't mean that the version we're talking about for free is extremely limited. There's some things it doesn't do. Let's see if I have a screen that shows what they don't do. That. So some things that are not built in that are some of the AutoCAD integration features. You can do some basic tie-in and bring some of these drawings into AutoCAD, but if you want to directly output your output from the HSS software into AutoCAD, you need to use the Pro version. All the Hydronic stuff is included in the free version, but if you want to do steam, then you would have to upgrade to Pro. And if you want to do anything on the air side, you'd have to upgrade to Pro. But if you're just doing chillers, boilers, condenser systems, fan coils, geothermal heat pump loops, things like that, then you don't need anything other than the free version. So hopefully that helps that. So with that, I'm going to switch over to the actual software screen, and I'll show you some examples on that. And then, like I said, if you guys have questions as we go, please type them in the chat box down in the bottom right-hand corner, and I'll do my best to answer some of those questions. All right, so I got the software launched here on my screen. This is what it looks like when you first log into it. And I got a question from someone already. Will it work on a Mac? That I'll have to look into because I've never had the need to look at a Mac before. So I'm not sure about that, Ed. We'll look into it and get back to you. I don't think this version does, but there may be another Mac version, so I'll have to look at that and see. So I'll do that right at the end of the webinar here. I'll see if I can find it real quick. If not, I'll email you the answer to that question. So on the software here, when you first load it up, if you've used it for the first time, there are some preferences it'll prompt you to set up. I've already done those preferences. You can change those preferences on a project-by-project basis. The way you do that would be to right-click on your screen, and if you move down to Properties, you'll be able to change those on a job-by-job basis. So in this case, I can change the name of my project. Obviously, I'll just call it Test. Location. And you can pick which geographic weather data you want, and it remembers which one you used last time, and it'll default to that. So in my case, I've picked Chicago, Illinois. That's my general weather data. If you're in a different state or country, obviously you can pick that. And pretty much everything that you'd see in any other program that uses ASHRAE data is going to be here. If I check that weather data, it's going to bring up the weather data that's typically recommended by ASHRAE for, I think it's 97% scenario. Maybe it's 98. But you can see here for the cooling season, Chicago 91 degrees, 75-degree wet bulb. The heating season -6 degrees. So that's pretty normal stuff. If you don't like those and you want to be the guy in Chicago who always uses 95 -10, you can uncheck the box here, and then that makes these white. You can type in whatever data you want. I'm going to go ahead and leave mine as is. I'm not going to change that. And then as I move down here to the project properties, I can go to units and measure. Somebody did ask me if you can do it in metric, and the answer is yes. You would just click the metric button. And then further, if you want to use SI units for your metric, you can check that, or you cannot. We'll leave it on English since most of you guys are United States based on this webinar. Some of the options that are of interest, you can change the size and spacing of arrows and line segments. That's all just preference type stuff. Under the Hydronic tab specifically, the first time you use the software, most of these TACO options by default will be checked. I've unchecked them in my case. I only use them on occasion. But some of the features on there, like the TACO Twin T and the load match and things like that, I may or may not want to do on a project-by-project basis. That load match, basically, for every time I put a fan coil in, it's going to give me a pump for that fan coil to control it. Versus many other projects where I might have one central pump, and then I'll have zone valves at my fan coils and my radiators. This guy's going to put a pump at every terminal unit. So I typically turn that off, although you don't have to. The twin T, what that is, it's just two closely spaced T's that are built into one product that you sweat in. So some guys like that, some guys don't. I have it defaulted off for the purpose of this webinar today. Other categories of interest, if you click on piping here, you can specify the default type of pipe that you're going to be using when you draw up your piping diagram. In this case, I have mine defaulted to copper type L. I can pick something else if I want. I could do this all in steel if I want to do it that way, right? Depending on what I'm going to be doing, I can use PEX, I guess, if my local municipality allows me to do indoor piping with PEX. For right now, I'll just keep it on type L. And then what you can also do is check off sizes that you do not want to use. So in this case, I have 3.5 inches checked off because it's a really oddball size and it costs more than 4-inch pipe anyway. So I got it turned off. So it never tries to draw something with that. What this system is going to do is when you draw a piece of pipe and connect it to something, fan coil or whatever, it's going to size the pipe for you, and it's going to do it based on the GPM that's needed and whatever sizes are available that you have checked here. Now, the fact that I'm picking copper type L doesn't mean I'm stuck using that for the whole project. I can certainly mix and match things, but what I can do is I can have it defaulted to copper right now, draw all my stuff in, and then if I need to go change a few segments to something else because they got some existing pipe of some older type or whatever, I can go change that piece of pipe specifically. We'll show you how to do that. I'm going to skip the steam stuff since the steam's not included in this free version here. And you can also specify the heating content of your propane and natural gas that's in your local municipality area. Under electrical, if you are out of the country like several of you guys are, you can pick 50 hertz. Otherwise, you'll leave it defaulted on 60 hertz. And you can also specify some of the voltages that you might be using on your specific project. So in this case, I got 460 volts specified for my large stuff, 120 for my small stuff. If the building didn't have 460, maybe I'd come in and I would put 230 volt, 3-phase, or whatever the building had available to it. It's not going to make a huge difference. Obviously, it makes no difference on the hydronic sizing, but if you're going to try to use this software to help you select your chiller and things like that, then it would become important. But for just doing the hydronic portion, it's not going to be really related. Under controls, this used to be something that was only in the Pro version. Now some of these features have made their way into the free version. So we'll try to add some control features onto some of these guys here as we go. Most of them are on the air side, but you can specify different points to add into here if you want. I have not added any into mine, but you can add in additional points if you want to do that and then overlay those on top of your piping drawing. Under naming nomenclature, everything we draw on here is going to have a default name appear on the screen. For example, if you add a fan coil, scroll down here for a minute. I can't find a fan coil right now. Well, if we add a cooling tower, it'd be CT. If we added a fire damper, it'd be FD. Let's find something else. Here's fan coil. Fan coil, FC. Expansion tank is going to start with ET. So those names are going to be defaulted in there. These abbreviations, if you want to change them, you can. Most people aren't going to change those. Under equipment preferences, this is where you can specify for different types of equipment what you want the default temperature ranges to be. So this one here is for a chilled beam system, active chill beam, where I have fresh air coming in, plus chilled water, and in some cases heating water. So I can specify the temperatures that I have for my primary air, in this case 54-degree primary air. I would not have a relative humidity of 90 degrees, so that's obviously a horrible default to have on a chill beam system for the primary air. But we'll put in some more reasonable levels here, just so you can see what it probably should be. It's probably going to be cooler too. I can put in my space conditions, what I'm trying to achieve, and then when I hit apply, those will all be saved. When I go to fan coil, I can see my defaults for those. Fan coil is default at 8067. That's the AHRI test condition for which we test fan coils at for all manufacturers. So that's a pretty good starting point. That's 80 degrees on the dry bulb, 67 degrees on the wet bulb. That's normal for a fan coil selection here. You can also specify whether you want your fan coils. Most fan coils are 3-speed, low, medium, and high. You can specify at what point you want your fan to be selected. I have these all selected via the design at high, and then obviously in low load scenarios we can turn those guys down. The other one you get to specify what you want is under the heat pump category. And most of those are going to be rated at 8067 on the air side as well. So you can change those defaults if you want. So usually for fan coils and heat pumps, I would leave it alone. For chill beams, it's going to be, you have to change it very frequently. You can turn on and off some of the various labelings on here. You can change color schemes, although at first I recommend you just leave it alone. Red for heating and blue for cooling seems to make sense. If I got a single piece of pipe that might be used for both seasons, then it would turn purple on the drawing. It's pretty normal stuff. Coordination file options. What you want to do on here is check every box available. If you don't have the boxes checked, you can't run those reports later. I'm not sure why they make you check these boxes, but once you do it the first time, it'll save it for the future. But you do need to be able to check all these boxes. Usually also this export as read-only is checked. I generally uncheck that. That way when the Excel file comes out, I can edit it how I want. But you do want to check all these ones that you can. The ones that are grayed out are ones that are only available in the Pro version. The ones that are in solid black, like a bill of materials, the control schedule, equipment schedules, those are ones you can check and run those reports. And I'll run those reports for you later after we do an example job. Then for whatever reason, there's another section that has the same information. Once you've checked the options here as being available, in my case for 1, 2, 3, 4, 5 of them, then once I go to the coordination tab, I can also check those and print them. So basically check every tab on here on the coordination file options, check every tab under coordination, then later on when you go to run reports, everything will be available to you. Then the last section really is costs. For my purposes, I generally don't fill these out because I'm usually just helping someone with a conceptual schematic. But if you are on the contracting side and you want to use this to help estimate your project, you can certainly do that. So you can go in and put costs for, and then, well, we'll skip duct for right now, but put in costs for your piping materials. You can put costs in for your controls wiring. You can put costs in for just about anything you want here. And when you put it in for your piping materials, you can also have it add in the labor rates that you're using and equipment rates that you have. So generally, I'm not using these because I'm not bidding products. But if I was, I can click on 1-inch pipe, for example. I can put in how much the pipe cost me per foot, how much a 90-degree elbow cost me, how much a T cost me, how much labor to take my guys to install these, what's my labor rate, all these kind of things. Most of you guys on the piping side already have your own estimating tools, but if you don't, if you're a small guy or whatever and you want to use this, you certainly can. Just, make sure you do some reality checks on the first few that you run to make sure it's in line with what you would have bid. So that's that. And I'm going to say OK. All right, so the only thing that really changed on my screen is the name and location that I had specified. So that on that very first tab, name and location, right here and here, that's what gets put onto the actual screen. If you want to zoom in and out, you can do it by scrolling your mouse wheel. Obviously, you guys can't see me scrolling my mouse wheel right now, but it should make my my font bigger, and I'll try to blow it up so you guys can see better here. There's also the plus and minus zooms up on the top here. All right, so let me check real quick if there's any questions thus far on the screen. Looks like there's not. If you have any questions as we go, type them in the bottom right-hand corner in the questions/chat box, and I'll do my best to answer them. Like I said, I'm not involved with the software development or anything like that. I'm just a user of the software, but I can probably answer most of the questions that most folks pop up with. All right, so let's actually draw something up here, and then we can add more things to make it more complex as we go. So the way this thing kind of works here, so you can see with my mouse here, I got several different categories here. Mine's already on Hydronic, but there's a wizard one here you can click on that can kind of walk you through some example systems. I typically don't use that. If you're using the air side version of the product, there's air handlers and rooftops and duct ones. If I click on those for me, you can see all those are grayed out. I don't have them available because I don't have the Pro version. I just have the free version. If I click on Hydronic, all my icons are colored. I can use all of my Hydronic icons. The Hydronic pipe, everything's live for that one as well. Then if I click on steam, they're all grayed out except for one, which is the steamy heat exchanger to go from hot water to steam. Obviously, I have to have the heat exchanger available in the Hydronic version, so it's live here. And then the control stuff for adding control annotations is live on here. So I'm going to start out in the Hydronic section. That's what we're mainly going to be drawing here today. And the way these icons underneath Hydronic are kind of broken down is these first sections here are my heating sources. If I hold my mouse over one of them and hover over it, you'll see that it highlights what it is. So this is Hydronic boilers. If I hit the little right arrow next to it, it drops down different manufacturers of boilers that I could pick. that are involved with sponsoring the software, or I can pick no manufacturer and just get a generic one, in which case I can pick different types of boilers. I can pick, you know, a fire tube boiler, a copper tube boiler, cast iron, a condensing boiler, different categories like that. Other heat sources that are available to me, if I hold my mouse over something, I can get my heat from a heat exchanger, from some other system, from a process or whatever, right, or another existing boiler system. Then I got some cooling related ones, so I have air-cooled chillers, same kind of thing if I hit the right arrow. It's got a couple manufacturers, or I can pick a generic style of a chiller, right? Then I got water-cooled chillers, same kind of thing. I can pick the type of water-cooled chiller I have, centrifugal, steam, whatever. Then I have fluid coolers, dry coolers, wet coolers, heat pumps I could use as my cooling source. I got cooling tower choices and sumps and things like that. Then I got all my pumping related stuff. So I got different types of pumps I can grab, right? I can get horizontal, vertical, I can get inline pumps, split case pumps, little, you know, small residential size circulators, etc. Also have categories in here for expansion tanks, for air separators, for T's, hydraulic separators, or twin flow T's. Then I have categories for specialty items like chemical feed systems. We can put a glycol feed tank on here or something like that for a snow melt. We have categories on here for storage tanks. If I need to add a buffer tank to a chiller system, or want to add an indirect tank on a hydronic system, something like that. So I have different tanks available to me as well. Then I do have a few other more miscellaneous categories, like different types of heat pumps that I might want to use. Instead of a boiler, I might use a heat pump. And then I have all my terminal type loads. So the red and blue ones do heating and cooling. The red icon only does only does heating, excuse me, and the blue one only does cooling. So if I had a cooling fan coil, I'd pick here. I can go under terminal. I can pick a fan coil, or I can pick a heat pump, or I can click a cooling radiator panel, radiated ceiling, you know, PEX tube in the flooring, things like that. A chill beam. Right, under heating, I have similar types of choices. Under terminals, I got fan coils, heat pumps, fin tube, radiators, flooring systems, unit heaters, snow melt system, things like that. Also under those categories, other than terminals, I can do a process if I'm trying to do a larger scale drawing, or if I got some specialty stuff. Like I've done ones where I've drawn up MRI units getting fed by a chiller, or I might have a swimming pool fed by a boiler system, so I might pick, you know, a swimming pool as my terminal where I'm going to dump all my heat, those kind of things. Or I could be using this for very large systems where I'm drawing out a campus, and I might want to show, you know, like a university campus, I might show some, you know, apartment buildings, you know, some residence type buildings, then some laboratory areas, and then, you know, some, you know, mixed use facilities, things like that. And then the last one's down here, some really special ones for fan coils. I want to pick certain kinds of fan coils to show up in my drawing, ducted or ductless type fan coils. As far as the piping goes, it's not going to really matter. But if you are using the Pro version and you have the air side involved, then obviously that would make a difference. Although it is nice if you pick the right type of fan coil that you're going to use, even on the hydronic only version, because that'll show up in all of your reports later, all your equipment schedules that you're going to use for bidding your project out. All right, so let's just start with drawing a simple project here. Let's just draw for right now a couple fan coils and a chiller just to get started. All right, so I'll go under these blue fan coils. I'll do it cooling only right now just to make it easy. I'm going to pick a fan coil. I'm going to plop them on here. So there's my fan coil on my drawing. Right now he's not piped to anything. He has no idea what his water temperature is. He has no idea what his loads are. So the first thing I'm going to want to do is change some stuff on him. So what I can do is I can double click on him, and he brings up some properties specific to that piece of equipment. So you can see on the heating side, I don't have any heating. If I wanted to add heating to this fan coil, I can just come over here and click heating, right? In this case, I had none. I said I was going to keep it simple. Cooling, I got to input what my load is. This software does not do load calcs for your building. You'd have already had to calculate the loads for your zones. There are other software tools available for that, obviously. But let's just say, for sake of argument, let's just say this is a 3-ton unit. So I put in 36,000 BTUs. Then what I can do is I can leave it automatically sizing itself based on a 10-degree delta T. Or what most of us normally do is I want to change my own water temperatures. A little box comes up and asks me if I'm an idiot, basically. And even though I am an idiot, I'm going to go ahead and take control of this myself anyway. So I'm going to turn off that automatic 10-degree delta T, and I'm going to put in my usual chilled water temperatures, which is 44 degrees leaving my chiller, 56 going back to my chiller. You can make those whatever you want, but that's what I normally put in for a normal system. So that's that guy there. He's got a default head loss of 5 feet for this fan coil. If you know what kind of fan coil you're going to be using, you can go ahead and change these. Getting the head loss correct for all these various components, fan coils, radiators, whatever, is important because that's going to later on dictate the pumping that we need, the head of the pump we need. So we do want to get those correct. That way when it sizes the pumps for us, it gives us a correct selection. As with all software, the data you put in is very critical for the outputs you get out. If you put garbage in, you get garbage out kind of thing. Right now I'm not picking any particular fan coil in mind. I'm just going to leave it at 5 feet just because. But if I had a specific fan coil I was going to use in this product, I would enter that here. So as I go down the list, I can enter more different things. The description, like I said, he's automatically tagging himself. He's going to tag him 1, 2, 3, 4, 5. That's fine. I'll leave it like that. Anything else I want to change here? The glycol one is an interesting one. I normally, when I draw all the fan coils out, I start with the fan coils on the drawings because that's where I'm going to know the load. I don't know what the load is on the chiller until I've already picked all the loads for my zones. So I normally draw the fan coils first, but I don't typically enter whether I have glycol or not until later on. Later on, I'm going to enter that at the actual chiller, and when I enter the glycol percent at the chiller, it's going to push its way back to all my fan coils automatically, so I only have to do it once. So for right now, I would leave that alone. If you know the volume of water inside the fan coil, you can enter that here. So let's say it's not 8 gallons. Let's say it's only 10 gallons, or let's say it's not 10, it's only 8. I can put that in. That's going to become important because as you select your various chillers, they may have a minimum loop volume requirement of so many gallons to be fed to be available to that chiller. And if all your fan coils don't add up to that loop volume, you may have to add some tanks to it. So that's another important component. So we'll leave all these guys at the default for right now. Boom, boom, boom. We'll leave all the control stuff alone for right now. If I had a particular manufacturer I wanted to specify in here, I could type that in here right now if I wanted to. Oops. Can't type right. Let's just do multi-aqua since they're so kind to have given us this software. If I know the dimensions of that machine, I can put it on there. All that stuff is going to feed later on to my reports. If I don't know it, that's fine. Everything will be in the reports, etc., etc. So as you get used to this stuff, you'll know exactly which 2, 3 screens you got to change. I'm going to hit OK. You'll see a couple main things changed. One, it's got 36,000 BTUs, which is the load I said that zone needed, 3 tons. I got 44-degree water coming from my chiller, 56 returning back to my chiller, and it's giving me a flow requirement of 6 GPM. That flow requirement is based on the BTUs required. Obviously, the more BTUs, the higher the flow, and so forth. It's your normal calculations that you normally would do, but this is just doing the math for you. So now what I would do is I can connect this to a piping system, or in my case, let's just say I have a couple more fan coils and I want to copy this guy, so I don't have to go in and change things over and over again. So I can click on him one time, he gets highlighted. I can hit Control-C to copy him, or I could right-click on it and hit copy, either way. And then I can hit Control-V to paste the new one, or I can right-click and go to paste. And you can see there the shortcuts, just like all other Windows programs, the shortcut for paste is Control-V. So now I got another fan coil here. I can plop him down, and I can add another one with Control-V and plop him down. If I want to copy a bunch of them, I could highlight a whole group of them like that, hit copy, and then come over here and paste them, and I can paste a whole bunch at one crack. And you see how it's auto-labeling them, 1, 2, 3, 4, 5, 6, just putting them in order. I can obviously go change them if I want. I can also highlight these guys and right-click on them and then help line them up a little bit cleaner. I intentionally laid them on there sloppy so you can see how to line them up. So I can space them evenly from each other from top to bottom, which I was pretty close on. And then I can also line them all up, in my case, on the left side so they're nice and clean. All right? So the next thing I'm going to do is I'm going to add my chiller on here. This is only going to be basically a 10-ton chiller or so. So I'll pick a small air-cooled chiller. I could pick a multi-aqua one off of this list. And there's multi-aqua ones that have pumps in them and the ones that don't. I could also pick a generic machine off the list. So right now let's pick a multi-aqua one, and I'll pick one without the pump. That way you can see what it looks like when I add a pump in here. And I'll plop him over on this side of my drawing to give myself some space. And right now you can see he does not have the same water temps that I specified for my fan coils. But once I connect these all together, that'll get solved. He also has no idea how big he needs to be, because right now I have not told him which of these fan coils are going to be piped to him. In reality, I'm going to pipe them all to there, but he doesn't know that yet. There could be 2 separate piping plants on the same drawing. The way I draw the piping is up on the top here. There's this little arrow with the squiggly line. If I click on that, my mouse changes from the normal arrow type cursor to the squiggly line deal. All right. So I normally do is I just do it logically. I start with my water leaving the chiller and I draw my loop out. Everywhere I click my mouse, it's going to make a connection of the piping or it's going to make an elbow turn. So in this case, I'll click my pipe there. So now I got a connection. I can click here, it gets an elbow, elbow. And right now I'll just draw a loop around this building just to get something going here. I'll try to leave myself some room up here so I can draw in some pumps and stuff in a little bit. All right, if I want to get rid of that cursor, I could just right-click, and it goes back to my mouse, or I could have clicked up here on the mouse. Now I'm going to connect these fan coils in, so I'm just going to do these in a direct return type system. So tap him into the supply water, tap him into the return water. Now you see what it's done is made these dotted lines saying, it's great, you connected this fan coil to this chiller. I have no idea why the heck you got this extra pipe here, so I'm going to make him dotted. Anytime you see a dotted pipe, you got to fix something on the piping. But in my case, I'm going to wait to fix it until I get as much of my stuff as I want on here. So I'll connect this guy to the supply water, this guy to the return water, this guy to the supply water, this guy to the return water. And I can see most of my piping worked out to be okay. If I right-click my mouse, I'm back to my regular cursor. And I still have this extra piece of pipe which doesn't have any functional purpose, so it's dotted. If I click on that and highlight it and press delete, or if I didn't want to press delete, I could right-click on it and press delete that way. Either way is fine. Now that pipe's gone. It obviously wasn't important to me. You can see a couple different things happened. Obviously, the arrows showing which way the water is going to flow around here. So 44 degrees is going this way. Goes down to the first fan coil, returns back at 56 after he's added some heat to him, and dumps it back into that return pipe. This is a direct return system because the first guy to get water is the first guy to give it back. I can also draw a reverse return or whatever I want, primary, secondary, etc. The other thing you're going to notice is that my temperatures over here that I specified, 44 and 56, have now made their way to the chiller. So instead of 44, 54, I got 44, 56 on my chiller. You can see it also took all my BTUs for these three guys and added them up over here. So that corresponds to, I got 3 3-ton units, so that's a 9-ton machine that I'm going to need. And then my GPM, my total flow, is 6.1 GPM for each guy times 3. So that's 18.3 GPM will be my total flow for this particular piping arrangement. So let's add a few more things on here. First thing I'm going to add on here is a pump. So let's just do a horizontal inline pump because that happens to work well with the way I drew myself some space here. But obviously you can add whatever kind of pump you need for your actual project space. So as soon as I added that pump and dropped them on there, he automatically picked up that 18.3 GPM because that's how much flow I need to move this water to all 3 of these fan coils. And he got 33 feet of head. Now where did he get that 33 feet of head? What he's looking at there is he's looking at the pressure drop of the chiller, the fan coils, and the piping. So if you remember, if I looked at one of those fan coils, so go right-click on him and go back to Properties, one of these guys on here, which one is it? There we go. Hydronic head loss showed that I had 5 feet of pressure drop in that fan coil. Well, if this was really 4 feet on each one or 3 feet on each one, I can change that, right? Go to each one of these guys, change them to 3 for these kind of particular fan coils. So now you see, if I changed all of them, it looks like the worst one, obviously. So if they're all at 3 instead of 5, that saved me a little bit of extra feet ahead. So now I'm down to 30.1 feet ahead. Same thing with the chiller. If I right-click on him and go to Properties, there's several values associated with him. So he knows that he's 108,000 BTUs, 9 tons, because that's how many fan coils he has. If I didn't want to size him for the full load, now with 3 fan coils, I'm going to size him for the full load. But if I had 30 fan coils, and they're serving different sides of the building with different sun exposures and all that, my loads may not dictate to me that I need to do that. So I may size him for something else. So let's just say, for sake of argument, I size him for 80%. Let's just say that's my diversity for my load calcs. If I size him for 80%, then my chiller is going to end up being a 7-ton chiller instead of a 10-ton chiller, right? That kind of thing. Descriptions, no, they're going to automatically tag themselves chiller 1, 2, and 3. I should specify 2. If I had 2 chillers, right, instead of sizing one of them for 100%, for example, on my project, I might size 2 chillers at 50% each, right? Each of them will be a 4.5-ton chiller, right? So let's just do that real quick. So I added him in. Now you see he's only got 54,000 BTUs. and he's only going to be doing 50% of the load, right? And I could copy him, add a twin example on here, tap him into the same piping scenario. Just for sake of argument, maybe it's like that. Maybe I really wouldn't pipe it that way. I'd probably have a dedicated pump per chiller, but just to give you something to show here. So now each one of these guys is sized for 50% of the load. So that kind of thing. And if I was going to do them, you know, with diversity in there, then I can go in and change them and make each one of them 40% or something like that. All right, so there's lots of flexibility there on how we do this. So now they're each for 40% of the load. Obviously, 40 and 40 is 80. I'm not able to do the full load at the same time. But maybe my building doesn't need it. Let's put these back to 50 since it's a small project. What did I do there? Oh, 502% won't work. So at least it's smart enough to tell me that I'm an idiot. So you can see they auto-tag themselves, chiller 1 and chiller 2. All right, so let's go down the list here. If I wanted to check anything or change anything after I had set it up, I could do that. Here's where I could change the glycol concentration. So by default, as soon as I put an air-cooled chiller in, it said you're probably going to need glycol. Almost every air-cooled chiller manufacturer is going to specify a minimum of 10% glycol, and that's for all climates. And then once you start sticking it in the Midwest, like where we're at, you're probably going to be dealing with, you know, 30, 35% glycol, something like that. So I'm going to put in 30% propylene glycol. I'm going to say apply. Now if I go look at some of these other guys, since they're all in the same piping system, like I didn't pick it up. Let me see here. I must have to hit something else to get it to apply. All right, I'll get that fixed in a little bit here. Let's do it on both chillers at least. My temperatures, I already picked what I wanted there. Should also point out on this Hydronic here, the air-cooled chiller default component volume is 60 gallons. That's going to be the default if I pick a 3-ton chiller or I pick a 300-ton chiller. It's just the default that's in the software. So obviously that's going to be wrong for almost every single job you do, and you're going to want to look at the specs for the chiller you're going to use and put the right volume in. So let's say that this guy's really a 5-gallon chiller, right? And let's say this guy's really a 5-gallon chiller. All right, that makes a big difference on our loop volumes later when we look at those guys. Now you can see now that I changed both chillers to 30% glycol, now it did feed into my fan coils. Right? So if I would have left this at 10% and 30%, later on I would have gotten a flag saying that doesn't make any sense, dude. You can't pipe 10% and 30% in the same piping and expect it to stay that way. But once I got both chillers fixed to 30%, it did push over to my fan coils for me. All right, so the other thing involved in here, other than the pressure drop of the chillers and fan coils, we never got to pressure drop, did we? Here we go, head loss. So the chiller default pressure drop is 15 feet. That's going to be the way it is for every air-cooled chiller you use with the software. You're going to want to put in your real pressure drop. I don't know what it is for this chiller, but let's just say it's 7 feet. You know, whatever it is. And that's going to make an difference. If I change both of these, actually, it'll make a difference on the size of the pump I have, right? So I changed them both from 15 to 7 feet, and I went from 30 feet ahead on the pump to 18.5 feet ahead on the pump. So once again, garbage in, garbage out. I got to put the right pressure drop of the fan coils, right pressure drop of the chillers, and the right pressure drop of one other thing, which is the piping, right? Right now, it's assuming all my pipe is 0 feet long. Obviously, that's not real. So what I would do is I can click on any piece of pipe segment, right, and it'll highlight from that device, these green dots, all the way to the next joint. If I highlight it like that and I right-click on it, and I go to Properties, one of the things that actually defaults automatically to that one for length, it says 0 feet. Well, it's not really 0 feet. Let's just say that one's 100 feet. All right, so now you can see it went up to 2 feet of head loss just for that piece of pipe, which changed my pump selection. Right, I can go in as I decide how this building is going to look, and I can change it. Now, if I'm just drawing a pictorial drawing just to give my customer an example of how I'm going to pipe up their building or their house, I don't need to put that in. But if I want to use this to size the pumps, I got to put the links in of all the pieces of pipe that I'm going to be dealing with here, because all these pipe links are going to be cumulatively added to figure out how much head this thing's going to have. Right, so I'd have to go into each one of these pipe pieces and put in whatever the pipe loss is going to be. I'm just throwing stuff in here randomly right now just to get something in here. Right, you can see that the head on the pump changes as we go. Right, so what this has done for me is I've drawn the piping the way I'm going to pipe it. It sized up my pump for me, which is nice. I also need some other components, and it can help me size those. One of those is going to be the expansion tank. So if I click on expansion tank here, I didn't really leave myself a lot of room to add the expansion tank, did I? Let's make a little bit of room to add this expansion tank in. Actually, I probably want it on this side of the pump. I want to pump away from the expansion tank. I got a question that popped up from Matthew. For pipe links, do you put in the equivalent link, or is there a way to tell the system how many elbows and fittings there are? That's a great question, Matt. Let me show you that real quick here. So I'll right-click on this guy again, this pipe segment. I go to Properties. So I put in the link to pipe here. There is a section here. Let me find it where I can put in piping fitting factor. So by default, it's going to put in a piping fitting factor of 50%, so 1.5. That fitting factor is basically saying, tell me the real length of your pipe, and I'm going to automatically add a 50% penalty for all the elbows you're probably going to use. For a small system, that'll probably work out fine. For a larger system, you may want to spend more time putting in the right value. So maybe you only have 35% fitting factor, right? So you can punch that in. Or if you want, you can go in down here and you can put in the actual head loss of all your fittings individually if you wanted to. But the fitting factor probably works better. Most people use 50% as their fitting factor to begin with, so that's why it defaults that way. But you're certainly welcome to change it to whatever you think it's going to be for your project. So there's different ways you can do it. You can manually enter what the head loss is going to be of all these fittings, right? Or you can do the fitting factor. You get to pick. So the way I got to that is I went to a piece of pipe here, Properties, and it was under Hydronic fittings. Let me see if you could change it for the whole thing too. No. So what you want to do is, if you're going to do it a different way, after you draw that first piece of pipe, you go in and change him, and then when you started drawing after that, it would remember your settings. So after I drew everything else, it would remember what I wanted, if I wanted something other than 50%. So hopefully that answers the question, Matthew. All right, back to the expansion tank. So if I click on expansion tank, there's the different choices I have. I got full and partial expansion tanks. I can do diaphragms or bladder tanks. I don't know why you'd ever use a partial expansion tank. You might as well let this thing have the full expansion. But let's pick one of these tanks here. Actually, I better pick a vertical one so I got room to put it in the way I drew my drawing. So tap him in there. So as soon as I connected him on here, he automatically sized them at 1.7 gallons. Let's give myself a little bit more room here. So 1.7 gallons is what I would need for this expansion tank. That's a function of the volume that I've added here. So when I told it the length of all these pieces of pipe, it used the length plus the diameter that it's calculating for the pipe, which I'll show you in a minute, to figure out how much volume of water I have in the pipe. And I already told it how much volume I have of water in each fan coil, right? I told it that under, shoot, where did I put that? Oh, under key data. No, I didn't put it there. Where did I put the volume on here? All right, this is driving me crazy. There's too many screens. One of these screens has the volume of the fan coil we put in, and then the same thing on the chiller. We told it what the volume of our chiller was. So it uses those values plus the water temperature differential. In our case, it's chill water, so it's only a small differential, so I don't have a very big tank. If it was a boiler system, I'd have a much larger tank, obviously. I could also add in the air separators and components like that, right? So, oops. I don't want to do that. One of the weird things about this software is when you drop the device on here, you have to connect it to a piece of pipe. If I dropped it on here, then I tried to move it to connect to something, it's never going to automatically connect that pipe for me. Only the first time I drop it into the screen will it actually connect. So let's take that guy off for a minute. Let's give ourselves a little bit more room. Let's put the air separator on here. Boom. And let's see if we can tap an expansion tank off of the air separator. Once again, I didn't leave myself enough room. All right, so I can tap them in that way as well. Well, I messed the piping up a little bit there. But I can tap in the expansion tank off the air separator, which is what we normally would do on a normal system. All right, so with this, the next thing I might want to do is see my piping sizes. So one thing I can do is I can take my mouse and draw a box around everything I'm working with. So everything's highlighted at the same time. Then right-click on any of those things. And I have several choices of things that I can do, one of which is add some piping annotations. So if I go to pipe annotations and I click on diameter, it'll show me the diameter of each piece of pipe. So in this case here, my chillers are each going to have 1 1/4 inch pipe coming off of them. My main loop is going to be a 2-inch pipe, and my zones that are all identically sized are going to have 1 1/2 inch takeoffs, right? And then, as you can see here, 1 1/2 inch. When I add the 2 fan coils together, they add 1 1/4 inches times 2 fan coils gets me up to 1 1/2. Once I add the third guy in, I'm up to 2-inch pipe again. Right, so it sizes that stuff for you, and you can turn those on and off depending on which drawing you want to print at a given time. If I want to turn it off, I go down to delete. Oops, under pipe annotations, I go down to delete. I can turn off the diameter one. If I want to add something else in, and I can have multiples on there. If I want to add the flow or temperature at any given piece of pipe, or the head loss, or the lengths of all my pipe, right? So you can see I randomly put stuff in 5 feet, 100 feet, etc. Right? That way I can see real quick, oh, I didn't add any length for that piece of pipe. I better go fix him. He's really 25 feet or whatever he really is. Or if you're printing out a drawing for your guy in the field to actually, try to see how he's going to install this, that would be one way to do it. I'm going to turn that one off. Turn off the length. The one you're going to put on most of the time is going to be the pipe size. You can also put the flow on there and show all the GPMs and things like that. Let's put the pipe size on there. All right, now at this point, I'm fairly well done with this drawing. This is obviously a very simple system. So what I could do at this point is I can generate some of those reports. I could also take this drawing and use it elsewhere. So if I wanted, I can highlight this holding again. Right? I could right-click on it and say copy. Now I can go anywhere I want in my computer and paste that in a Word file, into a presentation, right? So I had this presentation I was using with you guys earlier, right? If I wanted to drop it on this slide, great. I can go on here and hit paste, and now it dropped it on top of this slide. Of course, I had a bunch of stuff in the background, but nonetheless. The idea, get rid of that other crap. I don't know why I'm messing with it because it doesn't really matter, but all right, and I could drop it on here and made it part of my presentation for you guys today or whatever. I could also paste it into an AutoCAD file as a single image. This would be different than bringing it into AutoCAD as editable file, which you can do with the Pro version. But if I wanted to just drop it on an AutoCAD drawing to supplement other stuff, I could certainly do that. All right, so that's one thing I could do is I can copy this drawing and do whatever I want with it, paste it in any program that I like. I could obviously print it as well, right? I can go to File and then print this screen. The other thing I could do is I could do some of those file coordination options that I mentioned earlier. To do that, like I said, you had to have those boxes checked. If I forgot, I could always come back in here and check them again. I don't know why they make you do that. If I want to actually open them, oops, I never saved this. I have to save it first. So let me just save this. I'll just save it onto my desktop for right now. I'll just call it project number 1. That's fine. All right, now I can go to the file coordination options, in theory. All right, so after it's saved, so now all the ones I checked that are available to me are actually available to me. So let's look at the very first one, the equipment schedule. This will open up in Excel. It'll take a few seconds. So it opens up in Excel, and I have multiple tabs down at the bottom, and it lists all the stuff that I can do here. I did get a question come in from Greg on how much the Pro version is. I think there's multiple versions of the Pro. I don't have it, so I don't know off the top of my hand. But on their website, I'm pretty sure it probably says on here, purchase. So looks like it's between $600 and $1,800. Probably, okay, $1,800 is probably what it would be if you don't currently own it, which most of people would not. So definitely use the free Hydronic version first, see how you like it before you spend any money on the Pro version. And then if you need those extra features, then you can certainly upgrade to it. Going back to the schedules, the first schedule here just tells me the name of my project and my design conditions that I based it on, right? Then I got different tabs down the bottom here for the different things that I have on my selection. So I got a tab for my air separators. In my case, I only got one, right? It tells me that I need to get air separator that handles a certain pressure loss. If I click on my chillers, I got 2 chillers in this case. I can add in the make and model that I want. It can be whatever I need. This one might be a multi-aqua. This one might be a bigger one. It might be a carrier, whatever it is. You know, you can put them wherever you want. If you don't like the refrigerant that it's showing here, you obviously can change that. Obviously, make sure it's something that's available from the supplier of the chiller. So this one down here would be a 410A machine, right? You can edit the tons and stuff like that, obviously, but that is going to really be dependent on what you did in your drawing. You shouldn't have to change those. Flow rates, water temperatures, glycol, things like that. If you got some limitations on your electrical, you can specify that information in here. If you got some dimensional limits, you can specify that in here as well. If you go down to expansion tank, so we only have one expansion tank on our system. It's telling me that I need to get a 2-gallon expansion tank. Great. Here's my fan coils. In this case, it picked me multi-aqua fan coils, which is fine. If some of them need to be different for some reason, I could type in what those are going to be. Maybe that one's a first company, maybe that one's a carrier, whatever. I don't really care. If I had a heating and cooling unit, I'd have more data here, obviously. It tells me the flow rate of each one, the water temperature, the fact that I'm using glycol, my BTUs. So anything I put on that drawing gets spit out into these different sheets. Now, it seems kind of stupid in this case to have all these different tabs for 1 or 2 items, but this was a very simple drawing we did. This software is very expandable to larger systems. So on some jobs, I may go to the fan coil link, and there may be 50 fan coils listed there, and there may be 9 pumps and whatever else. Our drawing was pretty simple in our case. But those are the different tabs that you can work with down there. That's one of the reports you can output here. All right, let's look at another report here. Another one is called the detailed report. I don't use that one very frequently. It's kind of the same information that is on that Excel spreadsheet schedule. It's just got a little bit more meat to it, and it's listed in a Word document, kind of one piece of equipment at a time with more details of the specs. So here's the air separator section, right? And I could edit these and change these how I wish if I didn't already do it in the software. What size is the pipe connection going to be? Does it have to be ASME certified? What's the deal with my chiller? What's the pressure drops in my chiller? What's the BTUs of the chiller? Do I have any devices on there? What's the ambient temperatures? What are the loads of the fan coils? Expansion tank, right? So I got more details on each one of these, and I can edit these as much as I want and turn them into kind of like a little spec. Here's the pump details and how the pump was even sized, right? So the pump was sized based on the pressure drops of all these different things on here: fan coils, chillers, air separators, all those things adding on there. The pipe links themselves, so it tells me why it's sized the way it is. So if I don't think it's right, I can go in there and look at it and say, okay, well, what did I miss when I try to do it by hand, for comparison purposes. Another one of the reports on here is the bill of materials. This one is fairly useful, assuming you actually put in the links to the pipes. Otherwise, it's a worthless report. But this, for a contractor, basically tells me what I need to go shop and buy, right? So I need to buy an air separator. I need to buy quantity 2, 4.5 or 5 ton air-cooled chillers. I need to get an expansion tank, right? I need to get 3 fan coils that are 3 tons each. I need to get pipe of a certain size, where I need 125 feet of 2-inch pipe, 22 feet of 1 1/4, that kind of thing. So it gives me a list of all the stuff I need, and obviously the more complex the project, the more and more pages we'll be printing out here. So these other ones here, this control schedule one is a relatively new one. And I didn't really turn too many things on, but it's going to give me a default schedule of what I might need to control this system. So, for example, here you can see it gave me a control schedule of the points that I might need to control the first chiller, right? So it's telling me I might need a control valve. I might not, but it's telling me that I might need that. I might need some emergency shutdowns. Probably don't on a job this size, so I can turn those off. Fluid flow detection, right? So a flow status switch, I probably do need to have that. Most chillers will require that kind of thing. Right, so it's giving me details of some of these things. Refrigerant leak detection, I'm not going to put that in an outdoor 4.5 ton chiller, but if this was a 1,000-ton centrifugal chiller, I definitely would need that, by code kind of thing. So it gives me stuff on here, and it's fairly detailed, and I can delete the stuff that I don't want. So maybe on this guy, I just need start-stop, I need the status, I need the flow detection, and I need the in and out water temperatures, right? So I don't need a lot of stuff for this guy. Maybe I just need those 5 values, right? Flow detection, in and out water temperature, start-stop signal, and status, right? Maybe I want to be more complex than that. So it gives me my chiller points and my my pump typical points. So like down here for pump number 1, I got a start-stop, I got a status, and then I also have 4 of them that are related to VFDs. If I don't have a VFD on my pump, I delete these before I print them out to bid this job out. If I do need a VFD, I'll leave it on the control schedule. And I also got generic sensors and stuff on here, right? And you can also, so that's just listed in order there by the equipment, chiller, 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 pump, pump, that kind of thing. And you can also have it listed here by the type of device that it's going to be, right? So what kind of sensor is it? Discrete input, discrete output, analog in, analog out. That way I can see which controller I need to buy. Okay, so let's add a few more things to this drawing, and we can make it a little bit more complex just to show you what it can do. So for example here, I got under hydronic pipe, I can add some devices on here. So I can add some control zone valves. So let's just add a 2-way zone valve to this guy. So put him on zone number 1. Drop him on there. So now I got a zone valve on there. I can add another one. And then maybe the last one is going to be a 3-way zone valve. And now I got the dotted line because something's not right. And obviously in this case something's not right, meaning I don't have the bypass line connected. So I click on the little arrow guy, draw the bypass line in, and now everything's good again. Right. Now I'm good back to normal here. Right, so it added those valves, and that'll slightly tweak what I got to do for my pressure drop on the pumps just because of the pressure drop of the valves, but it's pretty minor. But the other nice thing is it'll show up my reports. So if I were to save this again, oh, I got to close my other, I still have my old spreadsheets open. Let me close them. You can't edit the spreadsheet when it's already opened up. So let's just close those guys real quick. All right, so now back on my drawing, now I should be able to save my guy. Now when I go to coordination file options, if I open one of those up, such as the equipment schedule, got all the same stuff I had before. And then after my pumps, I got a new table, which is my control valves. There's one for the 2-way valves and one for the 3-way valves in this case. Right? If I look at these guys, it tells me it's going to give me a ball valve, bronze construction, modulating actuator. It needs to be able to handle 6 GPM and a 3.7 CV rating, and I want 24 volts. If I want to change that stuff, I certainly can change that right here. Right? If I want, for whatever weird reason, I want a 110 volt zone actuator, which I wouldn't want, but if I did, I could plug that in here. If I wanted to be made out of something other than bronze, I could plug that in. If I wanted, a globe valve instead of a ball valve, I could change that. Although for a zone, I would just leave it like that. So it gives me those schedules. Once again, this is kind of silly having a schedule for just 2 things. But as I add up, 10, 15, 20, 50 zones, having all those valves listed here with all the CV ratings that I need to go specify and buy, I'll be much better off that way. All the stuff that this is spitting out in terms of sizing and stuff like that is very accurate, but like I said, it's depending on the values you put in. So if you put in all the wrong loads or all the wrong pipe links and things like that, you're going to get jacked up data. So it saves a lot of time if you put all the data in, and it gives you very professional looking reports you can use to shop out your project. Actually, real quick, let's just look and see what that did for our controls schedule. I should have a few more pieces of data on here. So in addition to having my chiller points and my pump points, I've gotten 3 new points on the bottom for my control valves that I need to control here. Now obviously, if you guys that know controls, you're going to know that I'm not going to just have one single point to control the valve on a fan coil. That's just the one hydronic point that I have. I'm also going to be looking at some airside points like space temperature, duct temperature, stuff like that. So this control schedule on this version here is just showing me the hydronic related stuff. I'm still going to have airside control points for some of these pieces of equipment that I need to go monitor. Not so on the chillers and pumps, obviously. But when I get to a device like a fan coil and his associated control valve that's combining both airside and waterside, there's going to be more stuff I got to do. But this just gives you a nice report as a good starting point. Let me close those guys out. All right, so does anybody have any questions they want to type in the bottom chat box? If you do, I'll try to answer them right now. But like I said, this is just one example, something I could draw. Other things I could plop on here, I don't have time to draw it, but I'll just show you what some of these other things look like real quick. For example, if I wanted to put in a snow melt system, I can click that guy here, drop him in somewhere, and I can also keep making this drawing larger and larger as I go down here, right? Keep tapping stuff in. Now I'd have to have a boiler drawn on here and everything like that. The snow melt system is just going to draw in for me. I'm going to connect him to my regular, hydronic heating system. I know I got a chill water system on here right now. I'm just showing you as an example. I go tap him into those type of things, right? Trying to go too fast because I ran out of time today, but go tap him in. I wouldn't make it look like that because that's hideous, obviously, but and I could change his water temperatures by right-clicking on him or double-clicking on him, and I could change his values and so forth. It's not going to help me size the actual radiant tubing in the concrete. It's just going to help me connect that guy to the indoor piping loop. The same thing will happen if I throw a geo system on here. So that would be under geo. Where's ground loop at? Well, there's radiant ceilings and radiant panels. I could draw those in. Same kind of thing. It's not going to show me where the tubing's going to lay in the ceiling under the tray. It's just going to help me connect to that. That's fan coils. So let's see. Here's a swimming pool. I could drop him in. I could show you connecting piping to him through a heat exchanger if I needed to, which would be way back over here. All right, hydronic to hydronic in this case. I could pick a plate and frame or a shell and tube. I could drop him in, and I can connect both sides of that guy into here. And I would connect the other side into my regular heating system and so on down the line. And I'd have to specify what temperature I had on both sides of the heat exchanger. There's quite a few things I could draw on here. The only thing, like I said, that is really limited on is I can't draw tubing or geopipe in the ground or in the concrete for radiant. I can just show what it looks like when it connects to the actual load. I can't seem to find the geo. There's the geo. Okay. So if I had a geo system here, I could pick an open pond type loop, or I can pick a trench loop or a ground well type loop. So it would just show me connecting that up to my building, and I would size it and everything, but I would do that with a third-party software. So if I had a pond, I'd connect it like that, whatever. There's different things I could dump it on here and have it do. So what else? With that, we're pretty much out of time. I'm going to stay on here for 2 or 3 more minutes. If anybody has any questions, type them in. Otherwise, you're also welcome to call me, and I'll try to answer the questions later for you. My number is up on the screen right now, and my email is as well, so you're welcome to send me any questions. Like I said, it's a free software. You can download it from Multi-Aqua's website or get it from your Takeo guy, either way. And give it a try, and if you like it, start using it. If you like it a lot, think about whether you need to buy the Pro version or not. And with that, thank you guys for your time. I'm going to go ahead and stop this here now.